Okay, hi everybody. Thanks for joining our drone meetup. Tonight we have really happy to have Adam Krawczyk, who's going to talk about drones, ROS2 and AI agents, which is I'm really interested in. So I'm really looking forward to this. And I will just say thank you very much because I have to go to a conference tomorrow. I never got anything done tonight. So I really appreciate it, Adam. Okay, over to you.
Welcome. Hi, everyone. I'm excited to share how we are connecting AI agents to especially drones using ROS2 and Model Context Protocol. Yeah, I'm Adam Krawczyk, CIO at Wisevision. It's a startup I'm doing for like 2 years. A few words about me. So I'm a software engineer with a few years of experience. I worked at Husarian, which is a Polish autonomous robot manufacturer. Later, I was working at Robotic AI in digital twins. Now I'm working at Aptiv and doing the startup after hours. MCP server for ROS2, it's one of our projects that we developed, let's say, not on purpose. It came out to be something cool we didn't expect when trying to write it. But I will tell a little history about it later. So, obvious question: why bridge AI and robotics? Well, especially for you, I believe all of you understand that ROS2 it's like nerves and muscles of a robot. It handles all the low-level communication and control. And LLMs, on the other hand, are like the brain and language center. They can understand intent and generate solutions. But we need a clean protocol to connect them. Our goals are pretty simple: write less code, iterate faster on the ideas, enable shared autonomy, and make it super easy, whether you're experienced programmer or someone who doesn't even touch the code. So what exactly is a model context protocol? Like a year ago, Anthropic presented the MCP. It's super simple. It's like an API, but for LLMs, for agents. It's JSON RPC schema. It defines tools AI agent can call. It's adopted widely by ChatGPT, Cloud, Cursor, Warp. Pretty much every IDE now supports MCP. There is a famous example that MCP works like a USB-C for your computer, connects various protocols into one unified, let the LLMs use it like additional context. One thing is it's very similar to API, but kind of different. The thing with API is like when you give it to LLM, you don't have control on visibility what things the agent could call, can call. For example, let's say email. You would like to make an email, but not to send it. So just give the LLM access to write a draft, not to send it automatically to your recipient. And MCP allows to limit the API functionality in this way by showing only what's meant to be used by AI. How the MCP works. So there is a discovery loop, and this continues. Well, let's say this will be about ROS2 MCP server. So it works the way that it discovers the context, like discovers topics, services, and actions. Then adapter builds MCP JSON. Later, the web server or STDO interface expose the MCP endpoint. And finally, there is a runtime loop. The AI model receives context, emits structured intent, and call the service with those parameters. The runtime validates it and executes, return the results, and the model continues its reasoning. It's a kind of feedback loop that enables LLM to interact directly with the things it's working on in databases. Instead of guessing, it can check whether it can put some data inside, later receive the output of the database, check how it's changed, if it's changed by its own. So our MCP, it was written in Python plus RCLPy node, and we used the approach that ROS2 can be seen as a database, not the regular, but kind of, with disappearing history, without history actually. We made our tool for coding first. It was to help us write better code and agentic workflows. Close the loop so the agent, instead of only trying to checking the code by running unit tests or integration tests, could execute the node, publish some data, receive the output on its own, exploring areas we didn't thought of. Our idea is to map all the ROS2 API into MCP tools. We are close to finish it. How to start? If any one of you is using MCP, it's super easy. In our case, it's clone the repo, build MCP, add to AI client, and just run it. Now we have also support Docker, so it's without any cloning. And here is the first use case for the MCP, speed up code writing. The problem we had was that we were writing a drone controller for the simulation, and it was not flying as we expected. It was tilting, sometimes running into oscillations. So we came to idea that we can write the MCP, so the agent will start the simulations and auto-tune the parameters of drone by feedbacking the position of it, sending the twist command, checking how the pose is affected, and improving to match the real life behavior. So with this target in mind, the first thing was to support all possible ROS types, because when we are writing something to test the code, test the various topics, we had to support all the possible types. Best would be to let the LLM decide which type is it and chose the appropriate for subscribed, publish, and so on. We did that. It was working, but it didn't outperform us in this task, which is totally fine, because it turned out that it can do much more. So here's the first demo. Not only it works in writing code, but also in controlling robots, because LLM can understand how the topics are constructed, see the nested messages field. It can subscribe to any topic, understand what the values are representing, and well, in this case, the task was super simple. So go up and then forward. For human, it's pretty understandable what does it mean. For the agent, the reasoning was that, well, I need to check what's the topic for command velocity. When I have this command velocity topics identified, then I guess the value of velocity up, guess the value of velocity forward, and also guess how long it should take to flight. It's not something obvious. In this case, I guess it was 3 seconds fly forward. Yep, most of the LLMs are guessing the same, not the same, similar numbers because of the training. So, in fact, yeah. The second use case, maybe you remember the Ukrainian attack on Russia airfields. It was called Spiderweb. We tried with the MCP whether we can do something similar. These are actually 2 prompts only, and the first one was to make the agent understand the environment, see what's going on. So it listed all the topics, services, fetched the camera image, and based on that published information that it's a drone in simulation. It was quite shocking to me that it said that it's a probably O3DE simulation, which is true. It also told that it can see trees, high, plane. And the second, here it is, what the agent reported. It can see point cloud, LiDAR, velocity commands, rain, vegetation, aircraft environment. The second prompt was now fly in plane direction, which is also easy and understandable for humans, but for the robots, first it need to identify the image. Where is the plane? What is the plane? Then the relative position of the robot to the plane, publish appropriate command, and check whether it's closer or yeah, how it went. And it can do that almost without any issues. Reported that the aircraft is visibly bigger, so it must be closer. It also said that it's probably yeah, the twin engine plane with yeah, the moving wings, etc. It's astonishing. Oh yeah, here it is. Please note that at any point we've given the information which topic we want to use, and anything regarded to ROS2 directly. If I'm moving too fast with the screenshots, let me know to stop.
You're good. Keep going.
So there is one new thing about MCP as it's evolving. It's called MCP prompts, and this is special I have for you. So it's a reusable structured message template with rich context, standardize the process. And here is the QR code for the demo branch of the MCP. It should be linked to the instruction how to run gazebo simulation and try it on your own, how it works. So here is first demo about prompts in action. It's on our GitHub, a gift. It's linked to Mavlink. We are using DJI drone with Mavlink, so it's published ROS data. And the created prompt was very simple, and the task was to go up then to the desired altitude, then whether it should land or not. The agent understands that it needs to arm the drone, then set up appropriate mode, fly up, and after reaching the desired altitude, fly down around the drone. And here is the demo which is made for you. So it uses standard gazebo simulation, which is included in examples. And on this demo branch, there is one prompt called fly in circle. As an argument, there are two parameters. First, it's radius, and the second one is velocity. The agent receives those two parameters and fly in circle as we expected. Also, without any knowledge about the topics, it lists them on its own, identify by the topics names, types, which one should they use. So about the performance, it doesn't really affect much the workflow. Bottleneck, it's still time to compute the LLM output. Packing into JSON, it's not a big thing. One thing we noticed, it works better with better LLMs. So if you're using GPT 4.1 or Cloud Haiku, then it will be probably performing slightly worse than Cloud 4.5 or GPT-5. Yeah, it's pretty much simple. The better brain is behind the protocol, the better output we should expect. So our roadmap, it's community-driven prompts, signal processing pipelines, lifelong mode, and we would welcome your any issues, PRs, so on. So what's the biggest benefit of MCP instead of writing, for example, your own model, training it, and using for your specific task? There are a few things, but first, which is for our startup, the most important, cost effectiveness. You only create it once, and you benefit of each iteration of the LLMs. We receive next model, and our MCP works with it right away. No need to do some adjustments, retraining, anything. It simply works better because the LLMs it's better itself. We are free on the train of working better, which is super exciting, and that's why MCP is so popular right now. The second one, it's a standard way, and some call the MCP a modern API. So we have a Discord server, and you can also see us there via GitHub. Publish any issues if you have some. So few takeaways. MCP, it's simple JSON schema. It works as USB-C. It can help improve code, allows agents to understand anything what's behind, interact with it, made for providing context to LLMs. In this case, it's ROS2 context, which works for any robots, including drones. Yeah, simply you can talk with the LLM, and it can control the robot. Yep. So that's it from my side.
Adam, I have a question. I don't know if there's any other questions in there yet. You said it works with DJI drones. Will it work with PX4 drones? Because it's based on Mavic too.
The PX4 are the best for it because it's ROS2 native. It doesn't require any bridge. So yeah, PX4 it's
cool. Okay, that's something I want to try over the weekend. Any questions from anybody else? Do you have, where is the GitHub repo? Maybe we could post that.
Yeah, here it is.
Okay, very cool. Any other questions before we close up? Not hearing anything.
So maybe that my CEO in the startup doesn't know about it, but if you write to me on Discord, we have a pro version of this MCP. The difference is that it can call many tools at once. Maybe not many tools, but it can publish to many topics at once, subscribe to many. So if you write to me on Discord, I can give you access to that. Link to Discord is on GitHub. I will be waiting.
Okay, sounds great, Adam. Thanks very much for doing this. I know it's really late where you are, so I really appreciate it even more. I'm going to be playing with your GitHub repo over the weekend, so I'll probably be bugging you if I can't get it working. Okay, thank you. Bye, everybody.